Hey everyone. So if you've ever actually built something with an LLM, you know the feeling, right? One minute it's a genius, the next it's just confidently making stuff up. Well, today we're going to talk about the fix. We're diving into a technique that makes our models not just more powerful, but provably correct. And really, the entire idea boils down to this simple but super powerful concept. When words aren't enough, use tools. This is the big shift we're talking about. We're moving beyond thinking of AI as just a chatbot and turning it into a real problem solver that can actually do things. All right, so first up, let's really get into the weeds on this reliability problem. To really get the solution, we have to understand exactly why these incredibly smart language models sometimes, well, get it wrong. Okay, this slide just lays it out perfectly. On one side, you've got your creative language tasks. Ask an LLM to write a poem, it's brilliant at that. But on the other side, you have reasoning tasks, things that need to be precise, like a financial calculation. And that's where things can get shaky. You get an answer that looks right, but is just a very confident-sounding hallucination. And this, right here, this is the heart of the whole thing. You've got to grasp this key difference. LLMs are reasoning engines, not execution engines. It can brilliantly lay out all the steps for how to calculate a profit margin, but it can't actually, do the math. So, if the model can't execute, what do we do? Simple. We give it some tools to help out. And that brings us to the core idea behind a really powerful technique known as program of thought. We've all seen this, right? Models are just incredible with code. They can spit out a Python script, debug a tricky function, or explain what some complex code does. They're totally fluent in the language of programming. But, and this is the big aha moment, while the model can write that code, it has no way to actually run it. So what do? We give it one. We give it access to an external tool like a code interpreter, and suddenly the model's plan can be executed out in the real world. And this whole powerful concept has a name: tool-augmented reasoning. Just think of it like building a bridge. It connects the model's internal world of just thinking about stuff to the external world of actually doing stuff. This lets the model call out for help, to use a calculator or a search API to get real, verifiable, factual results. Okay, this all sounds pretty amazing in theory, but how does it actually work in practice? Let's pop the hood for a second. You'll see it's actually a super logical, straightforward process. It's really simple when you break it down. It all starts with your prompt. But instead of just guessing the answer, the model generates a plan, which is usually just a little piece of code. That code then calls out to an external tool, like our interpreter. The tool runs the code, gets the 100% correct result, and then feeds that verified fact back to the model so it can give you the final and now accurate answer. Right, enough theory. What does this mean for you as a builder? What's the practical value here? Let's talk about the actual real-world superpowers that this whole approach unlocks for your apps. The most obvious superpower is, without a doubt, flawless math. The second you offload those calculations to a proper code interpreter, you completely eliminate mathematical errors. This is an absolute game changer for any kind of financial app. Scientific modeling, really anything where being precise is totally non-negotiable. Next up, just think about data transformation. Come on, we've all been there, trying to get an LLM to reliably reformat a giant data file. It can be a nightmare. But with a code interpreter tool, the model just writes and runs a little script to handle it perfectly every single time. Things like reformatting a CSV or sorting a list, they become totally deterministic and 100% reliable. And oh man, this is a huge one for anybody building real applications: guaranteed structured outputs. If you need a perfectly formatted JSON to hit an API endpoint, you absolutely cannot have the model messing up a comma or a bracket. By using a tool, the model can construct and then validate the output, making sure it's always API ready. So at this point, you're probably getting excited, ready to start building with this stuff. Awesome. But before you jump in head first, let's just go over a few quick and essential rules for doing this the smart way. Okay, here's your blueprint. Rule number 1, use a minimal tool set. Only give the model the specific tools it needs for the job, nothing more. This prevents it from doing unexpected things. Rule 2, always validate the tool's output. Treat anything coming back from a tool as untrusted input. And finally, number 3, build strong guardrails and a ton of automated tests to make sure your AI uses its new powers predictably safely. So when you boil it all down, here's the takeaway. Tools upgrade an AI's reasoning from just a possibility to a verifiable reality. They're the missing link that connects the brilliant thinker to a flawless doer. And that, of course, brings us to the most exciting question of all. We've just handed AI a toolkit to reliably and accurately interact with the world's data and systems. So the only real question left is for you. What are you going to build with it?